This is the last section of Chapter 11, Binomial Theorem. Hopefully this is review because you did learn it last year. The first thing we have is Pascal's triangle. Hopefully you guys are a little bit familiar with that. This is how it's designed. In order to get to the next row, you add the two preceding terms as the ones that are circled. All right, they are actually also the coefficients for a binomial expansion. So if we have this expansion, a plus b to the 6, it says find the expansion. So actually I'm going to expand Pascal's triangle one more row. So I have a 1, 6, 15, 20, 15, 6, 1. So that's my coefficients. So I start with 1 times the first term, which is a, to the 6th. Now the first term's always going to start with the biggest exponent and work its way down. The second term, that one is going to start with the smallest exponent, which is 0, and work its way up. So b to the 0 plus 6, a to the 5th, b to the 1st, plus 15, a to the 4th, b squared, plus 20, a to the 3rd, b to the 3rd, 15a squared b to the 4th, 10, nope, just kidding, that's not 10, that's 6. 6a to the 1st, b to the 5th, plus 1 times a to the 0 and b to the 6th. So to make it look pretty, here is the final final thing. All right, Pascal's triangle for the 5th. So we have 1 times 3 to the 5th, because that's the first term, plus, whatever we're in, 5. So 5 times 3 to the 4th, negative x to the 1st. Notice I put negative x in parentheses, because that's the whole term, plus 10 times 3q negative x squared, plus 10 times 3 squared negative x cubed, plus 5 times 3 to the 1st negative x to the 4th, and plus 1 times 3 to the 0 negative x to the 5th. Notice that your exponent should always add up to whatever the exponent is outside the binomial. So we have 5, 4 plus 1 is 5, 3 plus 2 is 5, 2 plus 3 is 5, 1 plus 4 is 5, 0 plus 5 is still 5. And this simplified. 243 minus 405x plus 270x squared minus 90x cubed plus 15 x to the 4th minus x to the 5th. Then it talks about using Pascal's triangle, and it would make no sense to do Pascal's triangle for the 100th row because you'd keep going on forever and ever and ever. Then we have what a factorial is on the bottom, which everyone knows what factorial is. On the back of the next page, we have how to find coefficients. You can actually do these in your calculator. They're combinations. That's what these are. They're a combination, so they are actually right in your calculator. So if I go to math, oh, no, I want to put a number in first. So if I go to the first example, which is 90, C4 technically, so I'm going to put in 90 math, over to probability, number 3, put a 4 in, enter. That would be what the coefficient is. So that's actually saying the 90th row of Pascal's triangle in the 4th position is this number. So these values are 2,555,190. This is 230,300, and that's 10. Here's Pascal's triangle right now as combinations. All right, it's another version of Pascal's triangle. And properties, and then what it is written. that way. It just use Pascal's triangle. It's probably the easiest thing. On this last page, we did, I'm not going to do A because that's a really easy one. C, just remember that this is your first term. The 2y, make sure you put it in parentheses and your exponents go on the outside. I'm going to do the middle one though. Okay, make sure you do it that way. That's the key. That's where I have the most trouble. Like, so if I'm doing, oh, it's to the fourth, so let's see here. Fourth row is 1, 4, 6, 4, 1 for coefficients. Say I'm doing this fourth one, this one right here. I would be doing 4 times x. This would be 4 third, 2 to the first, and then 2y cubed. Cubed is on the outside, so you're actually cubing the 2 and cubing the y. So that's what that becomes. So this is actually 32xy cubed. Okay, be careful of this. That's where I see the most mistakes. All right, we're going to do this middle one though. So the sixth row is 1, 6, 15, 20, 15, 6, 1. That's the coefficients. Here we go. Part B. So 1 times, this is our first term, negative 2 is the second, square root of x to the 6, and then negative 2 to the 0, plus 6 square root x to the 5th, negative 2 to the 1st, plus 15 square root x to the 4th, negative 2 squared, plus 20 square root x to the 3rd, negative 2 to the 1st, plus 15 square root x squared. Oh, wait, guess not to the 1st. This is to the 3rd. Just sorry about that. Negative 2 to the 4th, plus 6 square root x to the 1st, negative 2 to the 5th, plus 1 square root x to the 0, negative 2 to the 6. It's a lot of stuff there. Square root x to the 6th is just x cubed. Then we have negative 2 times 6, which is negative 12. Square root x to the 5th can simplify. You can simplify x squared out and leave an x squared x. Then we have square root 2, or negative 2 squared, which is 4, times 15, which is 60. Square root x to the 4th is just x squared. Then we have negative 2 to the 3rd, which is negative 8 times 20, so negative 160. And then square root x cubed, you can factor out an x and leave one x inside. And then we have 15 times negative 2 to the 4th, which comes out to be positive 240. And the square root of x squared is just x. Then we have 6 times negative 2 to the 5th, which comes out to be negative 192. Square root x is with it. And then negative 2 to the 6 is 64. And some of these can combine. No, they can't. Just kidding. No, they can't. They're all different terms. So that's our answer right there. Then if we wanted to find a certain spot, we have this formula. You should keep that. We need to know this piece of information. So find the term that contains an x to the 4th in the expansion 3x plus 15 plus y to the 15th. Well, to have an x to the 4th, it starts with x to the 15th and works all the way down. So x to the 4th is really the 12th term. If 12th term, then r is actually 11. It's one less than it. And our n is the exponent, which is 15. So now we just got to plug in 15c11. Then this x is really our first term, which is 3x. we have 15 minus 11, which is our 4. And then the y is the same kind of y thing there. Y to the r, which is 11. So 15C11 is, I don't know a number. 15, 11, one more. 1365. And then 3 to the 4th would be 81. 1365 times 81 is 110,565. Then we have x to the 4th, y to the 11th. Excuse me. The coefficient, we want to find the coefficient of x to the 6th and the expansion of x squared plus 1 over x. This one's trickier because there's a numerator and denominator that have x's, so stuff's going to end up canceling if we write everything out. To get x to the 6th, you would subtract exponents if we're dividing, right? So x to the 10th over x to the 4th we're going to use. And since this is a squared on top, it would be x squared to the 5th, which is going to help us because that's the term we need right there, the 5th term. So if that's the 5th term, then our r is really 4. Our n is 9 because it comes from the x1 on the outside. So 9c4, x squared to the 5th for our first term, 1 over x to the 4th, and then simplify. 9c4 is 126. This is x to the 10th. This is 1 over x to the 4th. 126 x to the 6th. The coefficient is 126. And that concludes chapter 11.